This conference will now be recorded.
How's everybody doing today? Thank you everybody for muting your microphones. We'll give it another minute or so until anybody else may want to join us. But this is pretty exciting. All right, while we're waiting, anybody got any good jokes? I don't. Yeah, that's right, Leo, no beard, right? I look about 20 years younger, huh? So you guys feel free to type messages or questions into the chat bar at any time, and I'm willing to stop the presentation to get into those questions. But I guess I want to thank everybody and say good afternoon. If you know me, that's great. If you don't know me, I'm Jason Greenspan, the sales manager and business development manager here at Stellar Industries. The goal of this inaugural webinar is to introduce you to Stellar, kind of a who we are, what we do, why we do it type deal. Every week or two, let's say every other week for now, I'm going to bring you a new installment where we'll highlight a specific technology that Stellar offers. It may be plated up copper submounts, it may be vapor deposited gold tin, it may be microchannel coolers. I'll decide on a bi-weekly basis, and then what we'll end up doing is talking about it for a brief time and then opening it up to questions. So it should be pretty fun. I kind of dig this, so this is great. So now that you all kind of know who I am, let's get into this. Stellar is 35 years old. I've been in business for 35 years and currently employ 44 folks here in Millbury, Massachusetts. We run 2 shifts per day, 4 days a week. That's right, we do a 4-day work week. And yes, it's as awesome as you think it would be. To give you a little timeline on Stellar and how we came to be where we are now, in 1985, it was founded by John Snook and Ron Visser, our former owners. And basically the goal was to introduce the world to aluminum nitride ceramics, because at the time, BEO ceramics were getting a bad rap about potentially being hazardous. As we know now, that has quieted down a lot, and with the proper precautions, BEO is still a very effective material. In 1988, the company started ceramics machining. So they were originally distributors of aluminum nitride ceramics back in '85, but they were just a 2-man operation. So they were bought out of their distribution contract. And they figured, okay, well, we're not going to be doing distribution of aluminum nitride anymore. Why don't we figure out how to process it? So John Snook, being an expert in machining of ceramics, they went and bought some lapping and polishing machines and figured out how to prep the surface for metallization. And so our foray into metallized ceramic began. In 1989, we introduced our first thick film metallized parts. In 1990, our first direct bond copper parts. We were in fact one of the first licensees of GE's patent for direct bond copper. So we've been doing that stuff a long time. That's 1990, that's 40 years we've been doing this. So we got a lot of expertise there. In 1991, we did our first thin film metallized substrate. And in 1995, we introduced our first plated copper submount to replace thick gold as a conductor. In 2012, we moved from Leominster, Mass to Millbury, Mass, where we are now. And in 2014, we achieved AS 9100 certification. In 2019, this past October, actually, we were purchased by Trump Photonics, a very large German company specializing in lasers for automotive steel and metals cutting, metal bending. I'm not as familiar with the types of products they offer because they're very sophisticated. But a lot of what you're driving around or in right now in a building, their stuff has helped make pieces of. And in 2020, we introduced the debut of our plating line. So we currently occupy about 33,000 square feet. Millbury is about 40 miles or so west of Boston and about 40 miles north of Providence. So we're pretty centrally located. Obviously, if any of you guys would like to visit us, now is not the best time, but we would love to have you visit when the health climate kind of quiets down a little bit. So what do? We metallize ceramic. And, you know, there are some great companies out there that do metallized ceramic, ones that specialize in just thin film or specialize in just thick film. But we don't really consider them, you know, competitors because none of them really do what we do, which is offer you 3 options for metallization. And we'll get into that in just a bit, you know, the types that we offer. But Stellar, you know, strives to be as vertically integrated as possible. And we still work with some of the best subcontractors in the world. If some of you guys are out there, thank you for your support. We couldn't be as successful as we are without you. But there's a lot to be said for controlling your own fate. So vertical integration to us is really important. We do a lot of stuff in-house, and I wrote down a list here, so I'm going to try and list them all. I'm sure I forgot some of them, but we lap ceramic, we polish ceramic, we dice ceramic, we clean air fire the ceramic, we sputter thin films onto ceramic, we evaporate thin films onto ceramic, we photo pattern these thin films, we etch these thin films, we sputter or evaporate gold tin. We plate on top of these thin films. So if you wanted to plate up additional gold or additional copper or something like that, that's very easily done. We screen print thick film metals. We direct bond copper, alumina, BEO, or aluminum nitride. We photo pattern these DBC substrates. We chemically etch these substrates, these DBC substrates, using either ferric chloride or cupric chloride. We plate the DBC, we dice the DBC. We can also braze or direct bond leads to the DBC. So you have a leaded substrate. And we can also put pure copper vias in there. And we're talking pure 101 copper, very little electrical resistance, so you're going to carry a boatload of current. Now that's a lot of stuff that gets done here, and that doesn't even include the QC stages that go into making each part. As I had mentioned a little bit earlier, Stellar is an AS 9100D certified company. And for those not familiar with AS 9100, just imagine your ISO certification on steroids. So it's a very complicated, complex process about continually improving the company and our quality system. So our QC QA manager, Lisa Nauman's done a fantastic job leading that charge. And, you know, that's great that I mentioned Lisa, because quality is paramount here, right? And it's obvious in the minuscule return rate we have from our customers. So any questions so far from anybody? I see some new folks in there. I see some blasts from the past. Roby, how you doing? I see one of our reps here, David Passfield, located in Northern California. All right, no questions. All right, so let's get into it. We'll talk about the types of metallized ceramic we offer. Some of you are our customers for one type of metallized ceramic, and maybe over the years never really got to know all the other options that we offer. So I figured we'd do this inaugural get to know you type thing. And then each week or every other week, we'll talk about a new technology. So let's start with thin film. Substrate materials that we offer would be aluminum oxide, 96% all the way up to 99.8%, and everywhere in between. Typically, we're going to polish thin film ceramic. That way we have the best surface to achieve the fine geometry you need. Substrate materials also include 170 watt, 200 watt, and 230 watt aluminum nitride. Beryllium oxide, 280 watt and 325 watt. CVD diamond up to 2000 watts per meter Kelvin. Now we can sputter or e-beam these metals in-house. And the metals include, made another long list, titanium, titungsten, platinum, palladium, nickel, chrome, nichrome, copper, gold, silver, and gold tin from compositions of 70-30 to 80-20. We do the photolithography with either dry film or liquid resist, depending on the application. And then we can achieve your circuitry by doing it three ways, right? We can etch it back, depending on your metal scheme. We can ion beam, which you don't want, or we can do pattern plate up, where we're actually plating up against the photoresist. And we can achieve features as small as 12.5 microns. And we can also plate up additional gold or copper onto these deposited thick films if you need it. In some cases, some of the copper submounts that we do, laser diode submounts, we actually put a very thin layer of, let's say, nichrome and then copper, and then we plate up copper up to 75 or 80 microns so that you can carry the current that you need to carry. And then thick film, same materials. We offer 96 to 99.8% aluminum oxide, 170, 200, and 230 watt aluminum nitride, and BEO in the 280 and 325 watt ranges. Typically, we print gold, palladium silver, platinum gold, or copper. And feature sizes are usually no smaller than 125 microns, so that's about 5 mils. And the paste thickness itself, so the conductor thickness, how much it sticks above the ceramic substrate, is usually about 6 to 13 microns. And then getting into DBC, substrate materials are a little bit different. For aluminum oxide, we can still do the full range, 96 to 99.8. But for aluminum nitride, we don't do the 230 watt. We only do 170 watt and 200 watt. We're getting there, but right now that's what we're offering. And then for BEO, only 280 watt. We'd love to direct bond to 325 watt. The grains are quite large, so we just need to overcome that. If any of you would like to do a development project on that, we'll share the pain, share the gain type deal to try and prove out that technology for you. We use pure 101 copper foil. Typically starts at about 300 microns, and we can bring that down to 50 microns. A lot of the companies offering DBC are not able to bring it down that thin for you, but we are, both chemically and mechanically, depending on what you're trying to achieve. Min space and trace size for our thinner DBC is about 150 microns, or about 6 mils. If you want to look at the smallest feature for 300 micron thick copper. It's about 430 microns, or about 17 mils. I just had to use my cheat sheet over here. If you guys want a copy of any of these design rules, you can get them on our website. You can email me directly. I'll send you design rules for all 3 metallization techniques. Back to the DBC. Sorry, I'm skipping around a little bit. Plating, we can offer you nickel, we can offer you gold, we can offer you ENIG, NPEG, immersion silver. And we can also, which we've done recently, give you thicker copper. So usually, DBC manufacturer is not going to exceed 300 microns. But we actually came up with a method where we can offer our customers 600 micron thick copper on a DBC substrate. Now, what's the min feature size? I couldn't tell you. I'd have to talk to engineering, but it is possible. So if you're really carrying, outrageous amounts of current, and 300 microns is not going to do it for you, tell us. We can beef that up. And being a custom house, custom manufacturer, we have a lot of flexibility and great willingness to work on new things. It's actually pretty exciting to work on new things. And we're the type of company who does things that a lot of companies either don't want to do or can't do. So we have a lot of value there. And I encourage you guys to call me, email me, visit our website, find me on LinkedIn, reach out. I'll get back to you very quickly, and we can help solve some problems together. And that's our first webinar. Anybody have any questions? Or want to talk about a specific subject? I'm not giving away any beauty secrets, so don't bother asking. Largest board size. So that's a great question, Leo. Largest board size for direct bond copper would be a 5.5 by 7.5 inch board, of which 7 inch by 5 inch is actually usable. So you want to actually come in from the perimeter of the board, because occasionally you can have some blistering or some voiding, and you get in about a half inch or 250 mils on each side. You really get into the sweet spot of the DBC. Any other questions? Okay, yes, smaller boards, overhanging leads on DBC. So I happen to have some samples here. So here's a good example of one of the boards that we manufacture with overhanging leads. This one's about 7 inches long by about 1 inch wide. And you can see we can get a little smaller here. And here's another good example. Right? So these are some of our leaded substrates. And Jeremy, yes, we do offer wraparound ceramic blocks. I think I have some here. There's definitely some on our website. Let me see if I can draw up a picture. Get a picture up here and I'll show you guys. Let's see. Okay. Now I'm going to share my screen. Jeremy, is this what you mean? Hang on, I'm just trying to get back here. All right. All right, yes, okay. Let's see. Hello, Allie. Yes, I hope this is also showing you the wraparound ceramic blocks. We would love to talk to you guys in more detail about your applications. If you guys have drawings or you want to have initial discussions, all you have to do is just drop me a quick message or an email. Let's see. Leo, just saw a Trump presentation where they're manufacturing laser welding systems for automotive. Do their systems and your copper leads play nice together? That's a good question, Leo. I don't know the answer. I could certainly find out for you, though, and get back to you. Let's see. I just want to make sure I didn't miss any questions. Here's a good example, too, of one of the boards, 5.5 by 7.5. And you see, well, what are all those patterns? What are they doing there, right? They look kind of haphazard and random, but there you go. This is one of the 6 that we get on this type of board. This is direct bond copper on aluminum oxide. And here, you can see by the color difference, direct bond copper on aluminum nitride. Now, we also have some samples. I'm sorry, eventually I'll figure out a better way to show you guys the samples. Let's see. It's a little thin film substrate right here. So it shows you, I don't know, it's getting blurry. It's probably getting blurrier. But just shows you what we can do. This is one here that shows there's a photoresist on it still. You can see by the green hue on the back. One of the cooler things that we're doing now, if anybody in here is using single emitter submounts for laser diode, you see here, look at that. Look at that surface finish that we're achieving on DBC. Most people would think that that's plated copper but on polished material, but it is not. That is 75 microns plus or minus 15 microns of direct bond copper on aluminum nitride. We figured out a much more cost-effective way to manufacture single emitter laser diode submounts like this. And yes, Todd, we can do vias. In thin film, we are working on a development project to do filled vias. In DBC, we can do them all day long. They are generally on the larger diameter range, somewhere in the 30 to 40 mil range, just because they were originally developed as not only heat sinking for larger pattern pads, but also for connection from top to bottom. So in this guy, hopefully you can see it. All these little pads on top are connected by vias to the leads on the bottom. Wraparound DBC is not something we do, but Jeremy, if you look at this part here, it is certainly something that you could do if we gave you the right amount of leads. Right? All you'd have to do is just bend that down and zap it with a little weld, and there you go. You got your wraparound. It's probably cheaper than trying to bond to the edge anyway. Let's see what else we have here. Here we got some lead-off technology that we offer on aluminum nitride. Now, we talked about the pattern, the big boards, right? I showed you this guy before. This is what it starts out as, right? So we do all the photolithography, pattern, develop, expose, etch. You have this, then dice and laser machine. You get this, and then hang on 1 second. This is a slightly different part, but similar shape. In this case, we do solder mask and a Hassel tin lead solder for our customer. So again, raw material, semi-processed, semi-processed, finished product. Sure, I'd love to talk about our coolers. Over the last 2 years, what we've done, Todd, is work with our mother company to develop microchannel coolers, both insulated and just copper, pure copper. So here you have a copper version. But typically, it's the ones that we're making that are insulated are sandwiched in between 2 layers of DBC, aluminum nitride DBC, and then you have 6 alternating layers of various etched material, etched copper. So you're forming little micro channels, and as we bond these layers together, we also bond them together with the DBC so that you're forming a sandwich. And that sandwich essentially holds a certain pressure when they have, you see here, there's an input and there's an output. The middle hole is just a fixturing hole. But then where they mount the laser, there is a specific pattern that causes turbulence as the coolant runs through the cooler. And the more turbulence you have and the right pressure you have, it does a fantastic job of cooling a high pressure or a high power laser diode. So it's actually pretty cool technology, and it really lent itself well to our DBC expertise. So while it took us a while to get our yields up, now we're consistently making them in the yields in the high 90s. So it's really a great product for us. And multi-layer substrates. Ali, do you mean in DBC? Let's see if I have an example here. I may not have an example of the multi-layer DBC, but we can, and we can connect the layers with vias. We actually did a free sample project for Tesla about 3 years ago. It never panned out, so I can talk about it. But we did a 10-layer DBC substrate where we connected with vias. It was pretty sophisticated. Not something I've seen any other DBC manufacturer make before. So bring it on. You want a multi-layer DBC substrate? We're the guys to help it make it happen for you. Thanks. That is neat. Any other questions? Thanks, Leo. So again, what I really want to encourage you guys to do is call me, email me. This cell phone is with me at all times. And I know I said earlier we work a 4-day week. My phone's always with me on Fridays. You can catch me after 5 o'clock Eastern time. I don't want West Coast customers to think, you know, their vendors shut down at 2 o'clock in the afternoon. So you can always reach me on there. Together, myself and Brad, with our engineering guys and our new engineering manager, Craig Denham, we'd be happy to assist you with new projects. existing projects, standard product. We can work with you from small volume. I mean, I just quoted some stuff today that was 10 pieces. You know, we can do 1 million pieces. With the coolers right now, who was asking me that before? Todd. I'm currently manufacturing over 1,000 coolers a week. With the capacity right now with existing staff and equipment to exceed about 3,000 a week. Any other questions? Could you do some assembly, different blocks together? You know, Jeremy, that I can. What is very interesting with the acquisition of Stellar by the Trump Group was now they bring a packaging and assembly expertise to the company. So we certainly could look at doing some packaging and assembly of your parts. If you'd like to send me an email, we can talk in more detail about that. You're welcome. Thank you. And Jace, I see you're there. I got your message. Sorry I didn't call you back yet, but I'm going to call you shortly after the webinar is over.
Perfect. Thank you.
You're welcome. Anybody else? Well, for any of your colleagues who may have missed this, I'm figuring out how to upload this to our YouTube channel. So I'll send out an email blast to everybody with a link to our YouTube, and you can share with your colleagues. I'll include my contact information in there so you guys can reach me anytime, day or night. Just call me. You know, I love this stuff. So let's love this stuff together. All right. Well, if there's no more questions, I'm going to end our first Stellar webinar. Thank you very much, Jeremy. Have a great day, everybody. I hope to hear from you all soon.